re-explain this real quickly, what we did, just so that people on the video can see what we did. So this is number 45 on the chapter, or benchmark 4 review packet. Says let S equal cosine squared of 3 minus t squared represent the position of a particle after t seconds. So we went in, we put that position equation in y1, and in y2 we did the derivative of y1, y3 we do the numerical derivative of y2. So we have our position equation, our velocity equation, and our acceleration equation. The first question here is during the first 2 seconds, find the 3 times when the acceleration is 0. So I went to window. It says during the first 2 seconds, so I set the x min at 0, the x max at 2. Our x's are our time. Wasn't sure what our accelerations were going to be, so I hit zoom 0, zoom fit. That gave me a nice graph. Then we go and find these 3 times. So for example, you hit second trace, number, we want to do the 0, number 2, because we're finding when the acceleration is 0. I could go a little bit left, push enter, a little bit to the right, push enter, and then back or across is push enter. Just lay it there, Jared, that's fine, thank you. And it takes a while, but it gives us, so which number is our 0? Which number is our time when the acceleration is 0? The x or the y? Yeah, x is time. Okay, so this is for 45A. Would you mind just pointing that for me a little bit, since I'm moving around? Just point over here for a minute. Okay, so for 45A, the acceleration is 0. One of those times would be t or x equal 0.89217, we'll say. Seconds. This one, I'm hoping some of you guys know that. What would that one come out to? Anyone tell me? 1.507? 06? Like that? Is there more decimals? Maybe we have more decimals? 5? Okay, that's probably enough. Okay, let's go 5. Normally, I want you to go at least 3 decimal places. But because I know I'm going to use these answers to find more answers, I'm going to go out 5 decimal places. How about this last one? You have that, Lauren, too? 954. Got another decimal, anybody? 0. Another one? That's enough, I guess, I think. Okay. Now, part B says find the velocity at those 3 times. So, which equation, how do I want to do that? What should I do with those 3 times? Plug them into your first derivative. Okay? So I could go to y equals, and our derivative is going to be our first derivative, which is our velocity equation, is this one. So I'm only going to turn that one on now. Okay? I'm going to hit zoom 0 again. So zoom 0. That'll refit my screen so that it looks nicely with the velocity graph. Again, this will show the velocity during the first 2 seconds. And I'm just going to trace to those points. So I'm going to hit trace. 0.89217. And my velocity is negative 1.702. So my velocity at 0.89217 seconds equals negative 1.702. My velocity at 1.5065 equals, I have to get trace, put that in, trace 1.5065, 2.9948, 2.995. My velocity at 1.954 equals negative 3.8995. really tell us, they tell us that T is in seconds, but they don't really tell us whether the position is in meters or feet, so we can't really say feet per second or meters per second because they don't tell us what our ladle is for a distance. Any questions about that? Turn that off. Thank you, Katie.